Say hello, people, and we are live. Are we live? We are live.
Live.
So, welcome to Antrea Live. This is episode 11 with me, Zach, Grayson, and Jay. You guys want to introduce yourselves here?
I don't need to introduce myself. Grayson, what's up? It's good to have you back.
Yeah, long time no see, G. I'm not sure if you guys know me. I've been here like once, and I mainly work on the Antrea network policy side, and recently I also work on the Antrea Windows. So yeah, good to see you.
Okay, cool. Hi guys, I'm Zach. So currently I'm working on the networking stuff on Tanzu. Previously I have worked on Kubernetes related stuffs like CI/CD, DevOps, and SREs, monitoring these kind of things. Yeah, nice to join.
Yeah, that's pretty cool. My name is Amim. I will be the host for today, and we are gonna talk about Sig Windows DevTools, Antrea, and a lot of Windows. So, welcome. Cool. Ford, go ahead.
Yeah. So, what's the plan for today? I mean, like, do you want to go over the news or? Oh yeah, you're going to start with the news, right? So this is going to be a really cool show because Amim is one of the major drivers of the Kaping project, KPNG, and he's also driving a ton of stuff in the Windows community around the kube proxy, and he also is doing a ton of work downstream at VMware. So like, I don't think he ever sleeps, and he's just been super deep in the way Windows proxying works, and some real deep internals in the way the kube proxy works. So he's going to teach all of that to us today. So big thank you for coming on the show. What's up, Doug? I see a lot of people here. Mike Zappa is here, which is cool. Another CNI. Pear is here, and Scott is here. So we've got all of our good friends are here. This is great.
Hey, hello, people. Thanks for
Go
coming.
ahead. Let's get started with the news. I mean, let's and thank you so much for running the show today.
All right, thanks for
I
inviting
can kind
me.
of like sip on this beer and hang out.
Cool. So we separated some news and some exciting stuff that's going on. So the first one is a refactor from Antonio. We had some issues with service IP allocation on cluster IP, so there are some conflicts in some cases where the initial IPs that are allocated as static IPs ends up conflicting with the dynamic IPs allocated. So to solve this, Antonio have the idea to refactor everything and create this cap for balancing the static and dynamic IP allocations on your cluster. So when you start a new IP server, like a cluster IP service, it gets the dot one in your list, and for DNS it gets 10. And then with what Antonio did was to get some step and base it on your CIDR, uh, create like this range to ensure things will not conflict. So if you are interested on this kind of cluster IP API server and how these things work, this is a very good read. uh, Next, we have CSI Proxy by James. Jamie created this post here. So this blog post is pretty cool. It shows up how to set up the CSI proxy with a driver, like the CSI SMB driver, and it allows you on Windows mount a new shared folder from your Windows service. So you have another Windows service and it can create like this mount, SMB mount as a storage class, and reuse this storage class as a persistent volume claim and mount this on your pods. And this is super cool. So you can use like this the full Windows sharing standard. It was at least like 20 years ago. I don't know right now, but you can use this mount on Kubernetes. It's cool. So next we have the 124 release cycle. This is started 2 days ago, and the release will finish on 19 April. So a lot of things are going to come into this new release.
Look,
we have
Jianjian is here, so we can ask a bunch of really annoying, hard Antrea questions now.
All right.
So this is great.
What's the first one?
What real quick? I mean, XQL, and I know Scott, Parent, and Doug are all here, which is great, and Mike. But XQL, I don't know who you are, but yeah, let us know where you're from and where you're coming from. It's great to see new people joining the show. That's why we're here.
That's great. That's great.
Also, we should really thank Jamie for that blog post, right, on the CSI proxy stuff. It's funny, I have a meeting about that tomorrow at work. Yeah, go on.
Oh, that's cool.
Yeah,
that's cool. You're gonna do another show about this, so
I don't know. Maybe they're mad at me. Maybe I screwed something up, and that's why we have a meeting. I don't know. We'll find out.
So the last news we have here in the list is like from all the exciting things that are happening, like finally Docker shim is being removed. Like it's not only deprecated, but it's totally being removed. Deems open a PR and this is merged and it goes to 124. So don't be scared because there are other alternatives, and this is pretty cool because we can use one only container runtime interface and standardize everything for how you run stuff, containers on Kubernetes. That's cool.
Yeah. It's finally out. So you were telling me earlier, I was telling Amim, I was like, come on, this is corny. Like, how many times can we make the same announcement over and over again? But then he told me, I didn't know this, that it's actually entirely deleted from the code base now. I didn't actually know that.
Yeah.
So Amim proved me wrong yet again.
Cool. So let's just start the show, our part.
Yeah. So I promised Amim I would at least give a quick introduction because he's already got a running system. We're going to talk about the Sig Windows DevTools project. So just keep that up while I vagrant global status delete and rebuild my environment here. So.
Okay, do you want to share your screen or what?
Yes, sir.
Okay.
I'm coming. Hold on, man. Hold on. Just give me a second.
We need some GIFs to put here. While we wait.
All right, I'm coming. Right, there it is. Okay, here we go. So, all right, I'm going to vagrant destroy my environment. Destroy CD source CD. So the Sig Windows DevTools is a project that me and Friedrich and Amim and several other people around here work on a lot. Jamie Phillips has helped us a lot on it. Some folks from Microsoft, Arvind over at Red Hat in the Sig Windows community. And the idea behind it is it gives you the ability to in just one command build a Windows cluster.
Sorry for the interruption, Jay.
Yeah.
Maybe you should zoom in a little bit.
Yeah, let's get screw this up every time.
Yeah.
Wait, is that better?
Yeah,
that's
better
better
for me.
So maybe we can get maybe since our friend Sig Windows DevTools. Let me while this DevTools here it is. Yeah. So maybe since Grayson is here, right? We can actually maybe we can get the Antrea folks to start using this more often. Right? So this is our
we'll
way.
Definitely give it a try.
You know who's Vicky tried it out recently. So or not Vicky Wenying. So this is our development environment for Windows. Nobody before this project existed really. There's no easy way to just like from source spin up Kubernetes and with a Windows kubelet with a real CNI that worked, right? That was like a big project. Like you'd have to sit there all day on a Saturday and Doug, I know you're here, and I was teasing you about this because you said you wanted to learn about Windows, and I was like, man, don't even bother. Just like give me a couple of months before we even start, because it's such a mess, right? Like, and there's no easy way to test it. I mean, there's great ways to run it in Azure and in AWS and in vSphere and other places, like with a production Kubernetes environment. But there's no open source, easy to follow automated recipe. So like we made that, and it's completely from source. And so I'm real excited about it. You can see we got contributors from Rancher, from VMware, from SAP, from all over the place, from SAP. And so I'm destroying my environment and making a new one. And that's really all it takes. You could just clone this repository and literally run make all, and it will compile Kubernetes for Linux and Windows, like the actual kubelets, and then it will deploy those kubelets, right? And then it will deploy them with the API server and etcd and everything else. And after doing that, it will put a real CNI, meaning Calico or Antrea. You can pick either one, even though I think I broke Calico yesterday. But it'll install either one of those CNIs for you, right? And then it'll spin up a cluster with one Windows node, one Linux node. And you can vagrant SSH into it, and you can hack around on there. You can run end-to-end tests. You can do all sorts of stuff on there. So it's a really great way to learn about Kubernetes on Windows on your laptop. Like, you don't need anything else, right? No cloud required. So that's the sales pitch. Amim is going to go deep into the details of how this works, of how Antrea works on it, and then something else real interesting about some of the like intricacies of like how some of this kube proxy stuff that we've been looking at, like in the KPMG project and other spaces, especially for Windows, sort of play into the whole Antrea proxy story. So, Amim, is that good enough of an introduction for us to get started?
Oh, that's great. Thanks a lot.
Yeah,
Okay, cool.
that's awesome.
So here it goes. It's polling and blah, 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 blah. And now we'll do cooking show. All right.
Yeah,
Go ahead
it's
and take
red,
over.
but it's working.
Yeah. Cool.
So, yeah, do you wanna show the files, like vagrant files?
Yeah.
Please, the beginning of
Let me
this.
switch over to here. Yeah. Let me open VS Code up. VS Code. Here we go. Cool. Let me know how this looks, if it's too small or too big. Oh, I'm in the wrong project. Here we go. All right, cool. So, yeah. So the way this works is like at the very top level, there's a make file, right?
You are not sharing your screen, you.
Oh, I'm not. Wait, here we go. Sorry. Yeah, at the very top, there's a make file, right? And so, the first thing we do is we fetch Kubernetes, we build the binaries, then there's this vagrant step, and then there's like a little smoke test, and we run a little E2E test, right? And so when you run make all, it sort of like does all these in order, right? And like what we do for CNIs is we kind of have forked some of the installation utilities for the CNIs, so that we could sort of have our own, so that it's kind of hackable. So we've like copy pasted code from Antrea and Calico into here, and these are PowerShell scripts, because again, like these are Windows installers for the CNIs on the kubelet, right? So what happens is when the Windows node comes up, it like runs this script, and this script goes off, and it sort of like makes these directories, and then it like runs these Antrea installation steps, right? And at some point we'll be able to entirely converge with Antrea upstream, but we found that it was easier for us to make edits locally in this repository, having sort of forked these scripts. We do the same thing for Calico, right? So for Calico, we do the same thing. We have these scripts. They basically do the same thing that the Calico installers do, right? But it allows us to debug things at a really low granularity inside of this repository, right? And we actually commit the Calico like YAML itself to our version tree. So for this helper is for Antrea. We should probably name it Antrea helper or something. And And so like these are the scripts that run after everything comes up. If you're interested in the Kubernetes SIGs image builder, so Amim has done a ton of work on this. Can you talk about this, Amim?
Yeah, sure. So I have a documentation. Maybe I have a README here that can help. Basically, what we do here is to copy these OVA like images that people are using on upstream. So there is a project called Image Builder, and we are reusing this Image Builder project to create our own version using the VirtualBox environment. So we can like get the same node that we are using downstream, like in production, to this environment.
Yeah.
And we can run like the same tools, the same software.
And the cool thing about that is like, you know, for vSphere, for Tanzu, for example, for Tanzu, we have we use Image Builder. Like if you spin up a Windows cluster on Tanzu or on, you know, CapZ, things like that, you're using Image Builder a lot of the times to build your images first. And Image Builder builds an OVA, right? It builds a executable, like an operating system that you can load. And so when you use Image Builder, it's like, well, how do you play around with that outside of a cloud? Like this is a really good way to do that, right? You can use the recipes in here to learn about Image Builder in your own little sandbox on your laptop. Yeah, go on. Go ahead, Amim.
Yeah, so I have a kind of small layer that, let me share my screen here.
Yeah, go ahead. What do you want to just take over from here?
Yeah, sure.
Yeah, you can take over now. So now we're going to transition sort of into the deeper part where we actually look really deep at the networking stack. But that's how you get started with the project.
All right, that's cool. So let's get more details on this image builder stuff. So this is pretty cool because, as I say, we are using beta tested process to create this image, and we are using like image builder is using this Packer. I think that's from HashiCorp as well, and this allows you to build new images and output this box here, and you can reuse this box. So basically, it's a bunch of Ansible scripts and steps that you can pass to configure the machine and build this machine with Packer. So this works pretty well and is a good way to package this image and reuse. So here we have a documentation on what we created and how we tackle this to integrate with our project here. So as Jay was saying, like basically this Vagrant file creates for us like two machines. One that's the control plane and the other is the Windows. So the control plane here is a Linux machine because we don't have Windows control planes, but the worker that gives you the second machine that runs this node is a Windows node. And this is where the cool part goes because we are using PowerShell scripts to bootstrap this configuration here. So after the process is pretty straightforward. So the first time you run this, the node joins to the cluster that exists, like here, and it creates like a lock and goes to the CNI. We support Calico and Antrea, but for sure Antrea is coolest. So we have like shell scripts that runs to install the CNI. So after you have like the CNI installed, you have your node joined, your node's ready to go. Before we go to this to the shell to show how these things work, I want to go briefly on how we installed Antrea in this, what this Antrea script does, and the challenges we had to bootstrap this Antrea Windows. Like I know Grayson is an expert on OVS, and
yeah, OVS was tricky, right? Like that was the tricky part, right? Because we OVS has to be installed on Windows, right? And it's not trivial necessarily to do that, you know. So yeah.
Yeah, so I would like to thank Alin that he is a developer on OVS and vSwitch and all this stuff. So he knows a lot of things about how to run OVS in anywhere. So he's a core developer there, OVN and OVS. So what we learn in this process, running these binaries here, like the OVS is the data plan. So Grayson, can you explain like what's the deal with the OVS in this Antrea architecture? I think you can do better than
yeah,
me.
because we probably have some people that haven't used Antrea much here. So can you explain what OVS does for people?
Yeah, sure. OVS is kind of work as for example, since I previously I'm mainly working on the network policy, and the OVS is kind of like the enforcement. They will enforce the network policy. Our network policy will translate to some open flow roles in the tables, and the OVS will doing the like the forwarding and also enforce the network policy, like this package should be dropped or rejected and something like that. Yeah, it's kind of underlayer it's a data path.
Okay, and I'll allow
Yeah.
it to say it's IP tables for Windows.
Yeah, it's like it basically does. Yeah, it's a virtual switch that lives in your, and so you could do anything with it. You could build your own software-defined network with it inside the kernel.
Yeah.
So we have a really cool episode with Grayson where I trolled him for like 90 minutes and made him like show me how to like go into the OVS tables and actually you can install Prometheus metrics and you can see what OVS rules are being written on Antrea. It's a really cool way to learn about how Open vSwitch works. But yeah.
Oh, that's pretty cool.
But yeah, all of Antrea is driven by Open vSwitch, right? That's the core technology. It's like Calico uses, Cilium uses ePBF, Calico uses, BGP and so on and so forth. And like for Antrea, the backbone of it is OVS.
Yeah.
And installing that on Windows that's kind of the real important thing that you need to do if you're running Antrea on
Yeah, absolutely.
Antrea as your CNI. Yeah.
Yeah, so on those scripts that Jay showed, I'm not sure if it makes sense to show this again, but you can show this again. There are a few
We have
steps.
we have a question from Mike Zappa. What's the hardware to offload capabilities of OVS? I'm sure Jiunjin has a very excited answer. I'm sure he's very excited to answer this, or Grayson. But what are the hardware offload capabilities, Grayson or Jiunjin or?
Actually, this is kind of like out of my range.
NSX. Can't you do it in NSX?
Yeah, definitely.
Right? Like if you're running NSX, then I think it can offload a bunch of stuff. I don't know if you can do it in other clouds, but at the very least, I know you can do stuff when you're running Antrea and NSX, and you could turn hardware offloads on and off. And it works faster and better in newer versions than in older versions. I think it's for UDP, but maybe it's for TCP too. Jiunjin says OVS support hardware offload of OpenFlow processing with supported NICs. Okay, so maybe that's how it works. Okay. And Pear is laughing at us. Okay. All right. Keep going. I'm sorry. All right, keep going.
Okay. So the first thing when we downloaded these binaries, like installing OVS from our script, basically the binary here, like what we need to spin up, like vSwitch or blah blah blah. The binary that we needed was not coming up, and the daemon was not coming up, and this service here was not running, and nothing was showing. Like you type the command and you press enter, and nothing was showing up. So talking with Ali, we discovered that there are a few libraries missing on this thing. Even if there was no output, like it's missing libraries, or I don't know. I was like, what is LDD to show me what's missing? And he showed me like this project here. This project can open the binary and shows you the dependencies of your binary, like an LDD can do. So we could get like what DLL is missing and download these later. So this is basically like it was missing the Visual Code C++ library, and I was missing like the SSL library. So by default, our image builder doesn't have that, and the Antrea package that we have upstream doesn't have that as well. So it was like kind of a pain to discover what was missing and was not on Windows. But that's cool.
Okay, so that's because so how come it works in Image Builder without a problem?
So I suspect we have a different version because we are using the same build. So that's one question. I'm not 100%
Someday
sure.
we should figure out why we never see this problem in Image Builder OVAs, right? But we only saw it in our VirtualBox stuff. Yeah.
Yeah, cool. So the other crazy thing that we spend a lot of time debugging and learning was when you have multiple NICs in your machine, it can kubelet and the CNI can choose like the wrong interface to do both the tunneling and bootstrap the node. So when you run like your node, a lot of stuff here, but when you do like your node and you get one IP, when you register,
Yeah. This is a Vagrant, yeah. So Vagrant is weird with IP addresses. So every time you spin up a Vagrant machine, it like makes a fake IP address for Vagrant, and then you get another one like on your private network.
Yeah, so we have two NICs, and this was not working.
Yeah.
We had to change this by hand.
So this is
make
cool
it
because we
configurable.
found an actual Antrea bug here, right? And then they made it so that you could configure the NIC in Antrea to right.
I think it was Calico with VXLAN, right? But yeah, Antrea as well. I remember. Yeah, that
We had a
you're right.
bug, yeah. Like I think they fixed it. I think it was Wenying that fixed it, but now in Antrea, it used to be in Antrea. I think it like did a default selection of the NIC or something, and like now I think because I filed an issue about this when we first saw this, and then they fixed Antrea so that you can sort of arbitrarily, like when it comes up, it doesn't just bind to the first device that it sees, which is what it normally did for Windows.
That's correct.
I have to look up the exact issue to remember exactly what the fix was, but I'll do that while you keep going.
Okay. So basically, this script runs like installs for two binaries, like install OVS, that's two services, and install kubelet and kubeproxy, more two services. So we have 4 services, and you have Enter agent, that's 5 services running on your Windows by this script. So that's everything that node needs to join in the cluster and start to treating the workloads it receives. That's basically how we install the CNI on this project. Some other crazy stuff we passed, like debugging. I think the hard part is to get the debugging stuff and like fix what's breaking. So, but this was pretty cool as well. The pod was not loading. Like we could schedule the pod, and the pod was like with some random error, like failed to reserve sandbox name. And I was like, wow, how we can solve this thing? Like I don't even have one error here. So
yeah, like in this case, kubectl describe wasn't working, right? Like so in Windows, if you have such a low level containerd error that like you could kubectl describe something, and if containerd, I think what we found, right? I mean, you were telling me earlier, it was like containerd was failing at the CNI level on attachment, but kubectl describe wasn't giving us the actual error for it, right?
that's correct. Was some
And
random
so
failure
then
to
you
reserve.
had to do this. So yeah, tell them about how you did this ETW event tracing stuff. Yeah.
Yeah, so this ETW event tracing, that's the default place that containerd puts his log. I have no idea how to get this thing. So James showed me how to do that in one project he was working on. And on Sig Windows, he created like this host process, and he created, I don't know what is that, Visual Studio Code, Microsoft things that extracts the data for you, the output for you, and prints for you. So you can like create a pod inside your node with this host process capability and extract this log. And for this, we need host process Windows feature flag because we are using by default one of the old versions of of
Yeah. So
Kubernetes.
yeah, and
And
in Windows, there's an event log thing, and it's like I don't even know what the equivalent of that is in Linux. Like I don't even like I normally would just tail a log file, but in Windows, there's this event log viewer, right? And
yeah,
like it's a thing. Like certain apps use it in certain places, and so
so I was like, okay, let's. What other approaches do we have here, right? So I discovered this service management thing that you can reconfigure your services on Windows, and then I could redo the path and add the logs, and now I could output the logs here. But I think that there should be better ways. So the problem is that we are using a CNI configuration from Linux with not existent CNI.
yeah, I mean, I guess Arvin's right. It's really just journal CTL, right? Like, I guess
I
that's
do
what
think
you'd
so.
call it. Yeah, it's the same thing. It's the same thing as it's like the log viewer for systems. Yeah, for systemd. Yeah.
Yeah. So what happened with these binaries here is that when the pod ups, the binary runs, so you can like allocate IPs and do more stuff, and you can configure the plugins, and the plugins reside on OPT CNI bin. And what happens that we bring the Linux version with binaries that are not here, so the output was not shown me, like the error was not being shown in the pod line, but enable containerd logs show me there, and this was fixed.
Okay, cool. Yeah, so these are all tricks. You know, the thing to keep in mind if you're getting into Windows and you're getting into Antrea networking on Windows or really any CNI, it's like these are tricks to keep in mind. Like you should reach out to us on Sig Windows and Slack. Reach out to Amim or Arvin's here too. He's fought with a lot of these problems, right? And you know, just ask us. But like there's tricks. Like there's for everything that you're used to doing in Windows, whether it's system CTL status or system or journal CTL, for example, like or you know, top or any of those things, like or PS, like there's a PowerShell equivalent. And so like we use those in Windows. It just takes a little while to learn what those are.
Yeah, shout out to James and Mark from Microsoft to teach me a lot of these tricky
Yeah.
commands.
They taught me a lot of it too. Yeah. Also, yeah. And Perry also showed me a lot of this stuff. Actually, and Stuart, who's not here. Yeah.
That's cool.
Stuart Preston, he's a PM for Windows at VMware. He's my friend. He tests all this stuff before our CI can test it. I don't know how he does that. Okay.
So cool. Yeah, the next topic like is something we are experimenting like so Kubernetes services and SessionAffinity, and now we can like go to the cluster and take a look on what we have in the cluster. I have two environments here. One is like a vSphere, and the other is the Sig Windows DevTools. If this fails, I have a backup. So
how many
it should
people in
be
the
good.
audience, do you all know what SessionAffinity is? Does everybody understand what it is and how it works in Kubernetes? Or have you ever used it? If so, like let us know in the comments. It's kind of a lesser known feature. When you make a Kubernetes service, you can give it this notion of SessionAffinity that'll have it stick to a pod for a while, as opposed to
Wrong,
jumping and load balancing naturally from one pod to another.
wrong answers only. So
Here we go.
basically, yeah. So basically, we have this session affinity by two things like known. We don't have any session affinity, or we have like session affinity by client IP. So your IP is binded to a particular pod if you request through the service. One of the only configurations that we have is a timeout. So it's like a time to leave for this session sticky pod thing. So when this expire, here we go again, Jay. So when this expires,
There's nothing easy. Scott's like the new Ricardo.
so when this expires, we expect the load balancing behavior to happen again, right? Yeah, that's mostly what session affinity is at this point.
Yeah. Paris saying that once the replica count changes, session affinity gets thrown out the window. I think Amim is going to tell us that what's throwing session affinity out the window is your TTL, right?
Yeah, for user space, I think the behavior is a little bit different, but yeah, that's what we're going to see right now. So cool. We have like 3 pods running here. Like we have this net shoot pod. This is like some fancy pod to debug networks that's the client. So we have one client. We have this service in the middle where
So
the
you got, this
client
is a
will
2-node
request.
cluster. You got a Linux box and you got a Windows box, and you've got pods running. These are all running on Windows pods. The who am I? Is that what you're polling against? For the
That's correct. So
Yeah.
what I'm going to do is like to put one pod on each node, so they are in different nodes, because we don't have like 2 Windows nodes. So we have 2 Windows nodes, the other environment we can test there. But right now we have like pod 1 on control plane and pod 2 on Windows, right? And what we're gonna do is get like this net shoot and do a request through the pod and see the behavior of session affinity. So we have like pod 1 here, and we have logs of the pod 2 in the second screen. Cool. So what
Yeah.
I'm gonna do here is to go to netshoot and do a curl in the session affinity. And
What's netshoot?
I don't know, it's some fancy pod, some fancy container.
It's like a debug
everything.
container for networking stuff.
Yeah, that's correct. So netshoot. This guy here.
Man, you're totally like TG. You're like totally doing like TGIK style, like just like, oh, let's see what this is. This is cool. No, go back. I want
That's
to look
right,
at
that's
it
right.
now.
Yeah, so you can, yeah, basically someone created this netshoot container where you have everything installed, and this
Okay.
we don't need to waste time doing AP to get install net.
Okay, so it's like, yeah, instead of doing BusyBox or whatever, you can just run this. Okay.
There you go.
Yeah.
So yeah, we are using this thing here. So my session affinity is 5 seconds, right? So I expect to have this load balancing going on for 5 seconds on each pod. So you can count this thing, 3, 4, 5, and then it goes to the other pod. This is the expected behavior of TTL, in my opinion. And that's how Antrea proxy is implemented in cluster IP. So when you say we have like 2 kinds of services, and 3 more kinds of services, but for this test here, we have 2 kinds of services that we are testing. Is a cluster IP, like the internal pod-to-pod IP, and a node port. And this allocates a high port in your node, is binded to your IP node, so you can access this from external places. When you use like a pod-to-pod in cluster IP, like with DNS and all this stuff, it goes through Antrea proxy of this node. When you do node port, we do through kubeproxy user space in this version of Antrea. Okay, I know we have a lot of features of Antrea covering that. We go on that later, but right now that's how it works. Node port goes to kubeproxy user space, and cluster IP goes to Antrea proxy. Antrea proxy is the equivalent of kubeproxy.
Yeah. So in this one, you've disabled. Oh, you're looking at node port services first, right?
This is a plain cluster IP call.
Cluster IP, yeah. So in cluster IP,
This is
we're
Antrea
only
proxy.
going to see the way that Antrea interprets session affinity, and then afterwards, he's going to show us node port services. And when you run Antrea, the version of Antrea we're running right now, and when you run Antrea and you don't, and you also run the kube proxy, the kube proxy the user space Windows kubes proxy will load balance your node port traffic for you. But the Antrea proxy, which is a newer feature some people don't know about, it replaces kube proxy, will load balance the cluster IP traffic for you. So you're going to show us cluster IP first, right? In other words, you're going to show us how Antrea proxy interprets session affinity first.
Yeah, that's correct.
Okay.
So cluster, what I'm doing is like I'm hitting the service right now through the DNS, and that is a load balancer across the pods made by Antrea proxy, and that's the behavior we are seeing right now. So as we have 5 seconds configured again, we are going to see 5 seconds being requested for each pod. So this is the session affinity being expired. And that's how it works, or should work.
That's how it's supposed to work. So in Per's
Upstream,
example here, where he says, you've got a client, it's hitting the same server and over again. It's like if it's like a user thing, the user's entering form data and they want their cookie to be cached or whatever, you might make the TTL for this service in your YAML spec for Kubernetes. Like you might make the TTL like 1 hour, right? Go to the same pod for an hour or whatever, right? And then in that case, you wouldn't get load balanced to a new place for like an hour.
All right, that's correct. Cool. So what we are going to see now is another behavior of a node port. So we are going to hit the same service, but using the high port. So I am expecting to have the same behavior, like after 5 seconds, it goes to the other pod. Someone can guess what's gonna happen.
Okay, so now we're looking at the user space proxy that's in Kubernetes in tree, and we're going to see how that works. So this is a really weird corner case, but we care about it in the Antrea community because up until one release ago, we still relied on the Windows user space proxy.
Right. So
for node ports.
At this point, I would expect my session affinity to get in place and go to the load balancer.
Yeah.
And go to the other pod. So this
we could see it's only all the traffic is coming on that right side, which means it keeps going to the same pod, right?
That's correct. So after the TTL, this does not happen on user space. So yeah, that's one crazy behavior that we saw and was not working as expected. And things can go even worse because there is a bug in the middle of this thing where the TTL is being ignored for user space. So
yeah, this is really, I don't know how long it took for you to like do these experiments, but I think this is great. So this helps us to like motivate to finish removing the user space proxy from in tree, right? It's been in there for a long time, but it doesn't really have much value anymore. So we're moving the user space proxy out, and this is yet another reason why we're going to move it out. It doesn't seem to have the same semantics as it should.
Yeah, it's important to notice that the user space is deprecated. We are like testing stuff, but you should not be using that in production by default. So we have other features on Antrea that covers the functionality. And this is the code that causes this behavior. Basically, we don't expire the session unless you do not request anything. So as you can see here, after you do a request, it saves the last user time. So this last user is calculated, but is updated only you do a request.
Yeah, this is a bug.
Yep.
You catch it.
So worse than that, this affinity type is not updated. So like this TTL second is not updated. What happens that the service creates this object here, the service inside the service map, and this TTL is never updated. So the default is always the default. The value you save in our client service stuff is ignored. So even in user space, even if you save some data here, like 10 seconds, it will always fall back to default because endpoint and services update are not saving this data here.
Yeah. So Gyunjin noted that, yeah, like now 1.4 out, like Antrea proxy does node port service proxying for you. So it's like these problems, you know, won't exist on, if you're running a newer version of Antrea, you could, for Windows or whatever, you can just use, you don't need to use the user space proxy anymore. It used to be we used the user space proxy though. And the reason is because Antrea uses OVS and OVS extends the Windows networking subsystems, and because of that sort of technical set of dependencies, you can't use the kernel space Windows proxy. But so user space proxy was a temporary bridge for us until we got Antrea proxy fully working with node ports on Windows and everything.
Yeah, that's cool. And at this point, there is an implementation of the same functionality most of the case. So it's totally advised to use this instead. Don't use user space. Yeah, that's what I have. So do you want to go in the next steps? And
yeah, I mean, what else do we have? I don't know. Do we have anything else?
Yeah, from our side, that's what we have.
Yeah. So cool. Yeah. So we're removing the user space proxy from core. We have, do you want to talk about KPNG now?
Yeah, you can go with KPNG.
Let me look. I'm looking up the HackMD. I here it is. Okay.
Okay.
Is it me? I don't know whose turn it is. Me and Amim talked about this beforehand. We're like, okay, I'll do this part, and you do that part, then I'll do this part. Okay, here we go. KPN. Yeah. So, all right. Yeah. What do you have next? Oh, we have the deprecation. We have the operational readiness stuff. So yeah, we should. Yeah, you're right. We should talk about that. So, part of what this sort of makes us, like, part of what this sort of like moves us towards. Let me share my screen here. Is this idea that like, well, we need to define. How do I? Oh, here it is. Yeah, we want to define these things for. We want to define the behavior of networks and of all this other stuff, especially on Windows, because you know we work a lot on Windows network stuff. But like in general, we want to define this. Looks like James has a suggestion. Let's just commit it, whatever it is. So, you know, and so we have a specification for the way Windows networking should work. And these are kind of like the core fundamental definitional things that we came up with. And some of these are implemented in the existing, or all of them in one way or other, you know, are mostly implemented in the existing Windows Sig Windows tests that come inside of Kubernetes, right? So if you go to Kubernetes GitHub, if you go in there, you go to the E2E tests, right? You'll see that there's a whole directory of E2E tests specific to Windows, right? And you know, so I think in all, I think there's like 25 total E2E tests split across these files. So like, for example, this hybrid network.go, like this test has essentially like all of the semantics of like, I think some of these, right? I don't remember exactly. But like there's other things that you care about, like stateful set IPs being preserved, endpoint slices working properly. And then there's like advanced networking tests, like for example, network policies, right? You know, and so in the existing Kubernetes end-to-end test, there's a test suite for network policies. So you can go here and you go to network and you go to blah, 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 blah. Here you go. So these support Windows as well now, right? So these support Windows, this test framework is in here. And this is actually me and Amim worked on this for a long time. But we added Windows to this not too long ago. So like you can test Windows network policies as well. The ability to test IPv6 and IPv4. I've never run the Windows end-to-end test for those, but I think they work the same. And so all these things are invoked using Ginkgo, which is a Golang tool. But what we want to do is make it so that we can define Windows, essentially Windows conformance, similar to the way that CNCF defines Kubernetes conformance, using sort of a specification that's easy to read and understand, like from a business perspective, so that like somebody running an enterprise Windows system can sort of go ahead and sort of like, without having to run this really complicated filter command here, where they skip certain tests and they add other tests, right? They can simply use a tool called Sonobui, which is one of our tools here at VMware. That it's an open source tool that is used for Kubernetes conformance to like sort of test whether their cluster is conformant to the Windows conformance specification. And then they can just have a flag like, does it support host processes? Does it support Active Directory? Does it support network policies, etc., right? Or they could just do all, right? And then that would give people in an enterprise who are running a Windows Kubernetes cluster the ability to really verify that all the basic Windows functionality is supported. So we're trying to like make that a thing. And that sort of plays in with what Amim was talking about earlier, you know, like with SessionAffinity, right? Like, I don't know if we actually talk about SessionAffinity in this Kep. We don't, but it's like the semantics of it aren't clear, right? Like the user space does one thing, the kernel space proxies do another. Project, you know, our Antrea proxy might do another thing. So that's kind of why we want to define these things in a really sort of deterministic way for Windows, as we see more and more customers on legacy systems wanting to run these Windows applications and know whether their cluster actually is healthy or not. And, you know, in full transparency, we're at VMware and we're just about to release our Windows on Tanzu fully supported pretty soon. And, you know, we've been sort of struggling ourselves with this idea of what does it actually mean to have a production Windows cluster, because so far there just isn't a definition for that in the community. And so for us, it's very important. We want that definition to be the one that we adhere to, but also to help other people. So I have a tool for this. If folks want to try it out, it's here. And it's, let me see. If you go into...
Are you already implementing this? Jesus Christ.
I have it in here somewhere. It's operator. I implemented part of it. So I have this, just a little bit of it. It's not the whole thing. It's not complicated. It's just a single Golang program that tries to, it takes in a specification, you know, and then the output of it is, you know, whether these particular features pass or fail or not. Right. So it's kind of a lower level implementation of this, but I want this specification eventually to like obviously evolve a little bit so that we don't have to put these actual tags in here. But this is kind of the way I would envision this. Like we would publish a YAML file like this so that an end user could just say, I want to make sure networking for Windows works. I want to make sure network policies work. I want to make sure the core stuff works. And then the focus and Ginkgo skip flags in terms of what tests are actually used and run in what context are sort of just part of that file. And then the user doesn't care about anything other than knowing core functionality passes, network policies, fast, GMSA fails, whatever, right? Yeah. And then we have the KPNG project, which is where we're sort of rebuilding. Amim, you have your PR. So Amim kind of owns the entire Windows story for KPNG. So the first thing that I think he's done is he's ported over the Windows user space to run in KPNG, which is the next generation kube proxy. It's a kube proxy that separates out the stuff that talks to the API server from the backends that do the data plane work. So right now we have IP tables, IPVS, and NFT. Pretty soon we'll have the Windows kernel space, the Windows user space, and you know, the Linux user space. So that's like how all this sort of comes together. And well, Zach's got a little surprise that he'll show you next week. But Zach, maybe we should just show them really quickly since you're here. So you want to talk them through the service load balancer stuff, Zach, that you're doing? This is our sort of new conformance suite that we want to build for services.
Oh yeah, so the Kubernetes service validator, right? So this is Yeah, we plan to do another show about it later. But currently, I can give an overview about this project. It's kind of like a Spear, so you can run in any existing Kubernetes cluster to validate the networking functionalities. So you can run with Envoy also. It will spin up a container. Spin up 2 pods. Which will do some validation on the networking in the cluster and then kill itself after it's finished. And then you can retrieve the result to your local and see what failed or not. The core of this project about is the metrics, actually. So we can see pod-to-pod connection. For example, if pod 1 can connect to pod 2 through node port or cluster IP, or can we achieve hairpin or SessionAffinity through the services? So yeah, the metrics can show you the result. The logic about this project is so it will testing the pod-to-pod connection through cluster IP, node port, load balancer, or external name, these kind of services, and also node port local, as shown in the chart, and then produce the metric, pod-to-pod connection metric. It will signify or implies it's okay or fail for the connection from pod-to-pod. Yeah. This project is originally created by Jay and Amim, actually, and this chart and this diagram is written by Amim. So I think it's totally making sense, and I think this validator is valuable to any clusters. Yeah.
Yeah. So Amim built all this like a while ago, like almost what was it, a year ago, Amim?
Yeah, maybe.
Yeah, so he built out this test suite about a year ago to give us like table tests. And the nice thing is these pods land on different nodes. They have an anti-affinity thing going on. So for us, like on a customer side, it's nice because, you've always got a customer and they're like, well, this pod isn't working. And you're like, well, does it work on other nodes? If you delete it, does it come back up in another place and work, right? And so like this just sort of solves that problem by giving us a table. These pods are in different places. And obviously it's CNI agnostic. It's kube proxy agnostic. So anybody who's like building a network tool or diagnosing a Kubernetes network can use this to like visualize where things are broken and where things are failing and what services are failing and why. But like Zach has sort of really polished it off and he's sort of taken on the role of like growing the community around it and building out all the details of it so that it is fully fleshed out, and so that we can really start using it at larger scales, maybe even donate it to Kubernetes SIGs. So reach out to him. It's Zach Yang. He's on Kubernetes Slack or in SIG Network. You can reach out to him and ask him for help running it, or you can reach out to me, whatever. But yeah, I think that's it, right? And he's going to do a full demo of this next week, right, Zach? Zach promised he wanted it to be perfect before he showed it to us, but I think it's perfect now, right?
I will try to make it better. Using this week. Yeah, let's see next week. Maybe.
I don't know how you drew that diagram. That was a really good diagram.
Yeah,
did you do that on your iPad?
Yeah.
Okay, he draws on his iPad.
Yeah, cool. We are getting a close hour.
Yeah, we're close to the hour. Does anybody have any questions? I see there's 16 people here, so this is a great show. A lot of people showed up. Does anybody have anything else they want to bring up? I know we got some new people who came in. Everybody say hi to Chinchi. She's going to start helping us out on the show too. She's one of our team members. She works on Avi, by the way. She's our new team member. Okay. Cool.
Cool. So,
anything else,
Yeah, that's all for me, Jay.
All right. Grayson, can you tell us what's coming up next in the Antrea front before we go? Or are you on mute? You're on mute, Grayson.
Hello?
Hey, Yeah.
Okay, sorry.
What's new? What are you working on? What any new features coming?
Yeah, I'm still working on the service account selector. I mentioned it last time. Like you can use the service account, either use the namespace or the name or the label selector to select some service account, and all the workloads or all the pods use this service account will be selected as a in the network policy. Like I can apply a network policy to all this service account that you cannot talk to other kind of another group of pods, or you cannot talk to the external, something like that. It's a
Okay.
easier way to select those pods using the
Service
service
account
account.
selector is a new thing. This is pretty cool.
Yeah.
Junjin is saying 1.5 is coming out next week. Grayson, you should have told us about that.
Yeah, that's a secret.
It's a secret. Okay, not anymore. All right, everybody, stay tuned. 1.5 is coming out next week. Next week, Zach is going to do a demo of the service load balancers with all the polish and all the bling. And then
On 1.5.
we're also going to do dual stack with the Tanzu Kakoni team. They're going to come. So next week is going to be awesome. Okay.
Cool.
All right, everybody. It was 5:01. Everybody say thank you, Amim.
Thank you, Amim.
That was great, man. That was great.
All right. See ya.
All right. See you.
Bye, everybody. Thanks, everybody, for coming. Thanks.
Bye.
Thanks for
Bye.
showing up, Mike. You got to do a demo one of these days, and Doug and Per and Scott and everyone else. Chinchi.
Peace.
Arvind.